Alright, let's take a look at this problem. In this problem, we're given this circuit here, and we're told to find the voltage across this resistance, 10 ohms, as well as the current that goes across it here. So, and specifically, we're going to use the superposition principle to find I naught and V naught. Okay. Now, the superposition principle states that if you have two or more independent sources, whether they're current or a voltage, so let's say you have 1, 2, then what you can do is you can turn off all the independent sources except one to simplify the circuit, do some analysis, and then do the same thing for the other source. So in this case, we only have two. So what we're going to do is we're going to turn off the 30 volts here, and then to come up with this circuit here. So when we turn off the 30 volts, what happens is we have a short circuit here, and then we're going to do some analyses to try to figure out what our voltage would be. In this case, we're going to change our voltage to V1. So what we'll do is we'll say this is going to be V1 instead of V naught. Okay, so we won't do that. And then we'll solve for V1 accordingly, and we'll set that up as well. And then the second thing we're going to do is we're going to keep the voltage source on, but turn off the current source. Now when you turn off a current source, what happens is it becomes an open circuit. So you have an open circuit here. So this is an open circuit, and instead of V naught, I'm going to call this V2, and that's important because of the linearity in the superposition principle. What we can say is our V naught is going to be the sum of V1 plus V2. Okay, once we figure out what V naught is, then we can simply use Ohm's law, V equals IR, in this case V naught IR, and we can rearrange this to figure out what I naught is, which is going to be V naught over R. So that's our game plan. This is what we're going to try to find, okay, by using the superposition principle. Okay, so let's go ahead and work on the first part of the problem. So we're going to come down here, and we're going to define, let me go ahead and define this point as node VA, this point as node VB, and I'm going to define my common ground here. Okay. As I do that, of course, I have current. I'm going to say I have a current coming in here. We have I naught going out there. I'm going to call the current coming down this way as I1. We have this current going up, and then I'm going to define my current going in this direction as I2. Okay. Before I continue solving this, I'm going to jump to the other one, the other circuit here, and in this case, just so I don't have duplicate, I'm going to call this VC. I'm going to solve them independently, but just so you see that we have I naught coming in here, we have the 4 I naught here, and what I'm going to do is I'm going to assume that this I1, I'm going to call this I1 here, going into the circuit. Okay, so let's come back to this first one here. So what we're going to do is we're going to do KCL at node VA. Okay, and what that's going to give us, so we're going to look at all the currents going in versus all the currents going out. So we got 6 amps going in is equal to I naught, which is going out, plus I1, which is going out. Okay, I naught is defined as VA minus VB over 10. So we got VA minus VB over 10 ohms. Then I1 is going to be VA minus 0 over 40. So I1 is going to be VA minus 0 over 40. So let's just keep that on the side there because we're going to utilize that to simplify this problem. Okay. So then we can substitute those in there. We got 6 equals VA minus VB over 10 plus VA over 40. It doesn't matter how you simplify this. You can multiply this by 100. You can multiply this by a common factor between the two denominators there, or 400 for instance, if you want a common denominator there to cancel out. But essentially, if you solve this, you simplify it, you get 240 equals 5 VA minus 4 VB. Okay, so we have an equation here that we can utilize. Okay. Next, we want to do KCL at node VB. KCL at node VB. And what's going into that? We have I naught going in plus 4 I naught, what's also going into VB, and what's going out is going to be I2. Okay, so we can now solve for this. We already know what I naught is, we defined it. It's VA minus VB over 10. Now we just need to know what I2 is. Okay, so let's go ahead and do that. I2 is going to be VB minus 0 over 20. Okay, so I2 is VB minus 0 over the 20 ohms. Alright, so now it's a matter of substituting these values in here. So I got I naught plus 4I, so that's 5 I naught, and I naught we said was VA minus VB over 10 is equal to I2, which is VB over 20. You can simplify this a little bit more, and we get I'm skipping some steps, but essentially get 10 VA minus 11 VB equals 0. Okay, so I skipped some steps, but you can convince yourself that's the case by doing the math. So now we have equation 1, equation 2. Okay, if we combine equation 1 and 2, we're going to come up with a value of VA equals 176 and VB equals 160. Okay, let's keep that on the side. Okay, so we got these guys here. So, but the thing is, we're not asked to solve for VA or VB. What we want to know is what V1 is. Okay, V1 is simply VA minus VB. So V1 is equal to VA minus VB, which is going to equal to 16 volts. So now we solved for V1. Okay, so we've got the first component here equals 16 volts. Next, we want to solve for V2, which we defined over here, V2. Okay, so let's go back up. we're going to repeat the same process, but now we're going to do KCL. Oops. We're going to do KCL at node VC from this second circuit here, which is going to give us the current going in. We got I naught plus 4 I naught, similar to the last one, plus I1 as we defined it going in. Okay, you can define it the other way, it just the signs will change, equals 0. Okay, so in this case we have I naught defined as 0 minus VC over 50. So I naught is going to be, this is going to be our ground here, our reference ground. So we have 0 minus VC over 10 plus 40, because they're in series, so that's 50. Okay, that's I naught. And then our I1 is going to be, in this case we have minus 30. Let me change this here. So we have minus 30 minus VC over 20. Okay, so we're going to utilize these and plug them into the KCL equation. So if we do that, we have 5, 0 minus VC over 50 plus minus 30 minus VC over 20, all equals 0. If we simplify this, essentially, let me do two steps here. Minus 2 VC minus 30 minus VC equals 0. Since we only have VC, is essentially what we get is VC equals minus 10. So we get VC equals minus 10. And now what we want to do is we want to figure out what V2 is. We scroll up. V2 is equal to, we're going to use Ohm's law, it's going to be I naught times R. Okay, and in this case we can define I naught, we already defined it up here. I naught, we defined it as minus VC over 50. So we're just going to plug that in here. Minus VC over 50 times R. Our R is going to be 10. So I'm just going to write it down here and then rewrite it. Minus VC is minus 10, which is going to be 10 over 50 times 10. And then V2 is going to be 2. So now we got V2 equals 2 volts. And that's the second part of this problem. So now we've solved this equals to 2 volts. So now V naught is equal to 18 volts. So we figured out what V naught is here. This is going to be equal to 18 volts. Alright, now that we have our V naught, it's simply, like I mentioned before, we can figure out our I naught. It's just going to be 18 volts divided by that resistance. That resistance is 10, and that's going to equal to 1.8 amps. And that's how you solve this problem using superposition. Okay, and the key is setting up your problem properly. The key is you got to make sure that when you turn off your voltage source, it becomes a short circuit here, and when you turn off, your current source becomes an open circuit here. Okay, and that's the solution for this problem.